Hi there, students. I'm going to go through with you today on September 30th the calculations that we worked through in class today on Kepler's second law. And we're specifically looking at Newton's law of universal gravitation, distinct from Kepler's second law, but still the same basic idea. If you look in your Google Classroom that I have up here, you're going to see that that was one of the things we did in class. And then you also were supposed to work on Kepler's first law and the worksheet. So that worksheet is right here in Google Classroom. You need to do this worksheet for Thursday because this worksheet is going to be very similar to the quiz that you take on Thursday. So please make sure that you take a few minutes and work through that. The only thing that I want to talk about with you right now is this second question here under number 1. What are the two conditions in which a perfectly circular orbit can occur? And we talked about this, but I'm not sure that we talked about it clearly enough for you to answer the question. So when we talked about this in class, we talked about there being two foci on top of each other. So you can say that as the two foci are on top of each other. You can say that as there's only one focus. And then the second condition is that F equals 0. Now, those two things mean the same, but those are two different ways to say basically the same thing, because you can talk about where the foci are, because an ellipse has two foci. So if those two foci are on top of each other, and also when F, which is the distance between the foci, is 0. If they're on top of each other, there's no lateral distance between them. So just make sure that you understand that from your notes. That's probably the only clarification that I think you need for this particular worksheet. Everything else, just use the notes that we took on the day that we did Kepler's first law, and make sure that you use those notes to help you answer these questions. This will be very similar to what your quiz looks like on Thursday. So for space systems, you were supposed to do the 4 problems here that use this mass 1, this mass 2, and these 4 distances. And so I've got this force of gravity shown to you. Is this what you got? Maybe, maybe not. It's okay. So one of the things that we talked about in class today is that, well, first of all, we talked about there's no crying in science class. This is a very first effort at this. Do not worry if you're not getting it right now. It's not that earth-shattering of a deal. There are some things that we will take away from these calculations. So if you still struggle with the exact calculations, when we start applying this with Kepler's second law, it's going to end up being more conceptual. There are some calculations that you can use to make your case stronger. But if you are just completely and totally lost in the calculations, if you can understand the concepts that we'll start to talk about probably late on Thursday and into Friday, you'll be okay. We're going to have a quiz on first law on Thursday. We will not have our quiz on second law until after fall break. So you can kind of breathe a sigh of relief about that if you're worried about it. Okay, so how did I get this number right here? I'm going to switch this over to my notebook, and I'm going to go through this whole process with you. Ignore this right up here. I thought I had space to write out the problems. I did not. What I talked about in class today is that it is always a good thing to write out the formula or formulas that you're going to use, and it's a good thing to write out your givens. And what I want to make clear about this is that when I took physics in college, this is very similar to how I would set up my problems. This is the first thing that I would do when I was working out a problem, because when you get farther and farther and farther along in physics, sometimes you'll have these different variables here, these different quantities, and you're going to have to use 3 or 4 different equations to get to the value that you want. So writing this out is going to help you figure out, well, this is what I have, this is the formula that I have to start with first, and then I can figure out a value from that formula and I can substitute it into another formula and I can find out a value from that and I can substitute that into a third or fourth or fifth formula. And some of the physics problems get that complex. I think they're fun because it's applied math. But when I have you write this stuff out, it's practicing. So you have some very basic set skills, just like you want to work if you're playing basketball, you want to work on dribbling, you want to work on crossovers, you want to work on going off the correct foot for a layup. You want to do all of those basic skills so that when you're doing things that are much showier, much more fun, much more complex, you have your basic skills in place. So that's enough about that. But that is why I have you guys go ahead and write all of this stuff out. There is method to that madness. So we know that the gravitational constant is 6.673 times 10 to the negative 11th newtons times meter squared per kilogram squared. This is a unit, newtons times meter squared per kilogram squared. A newton is a unit of force, just like a meter is a unit of distance and a kilogram is a unit of mass. Okay? Newtons tell you that you are um, dealing in force, and it is a specific amount of force, not something that you have to know now other than a Newton is a unit of force. Okay, you've got your two different masses and you've got your distance. So we're going to try to find what the force of gravity is between these two masses. Based on the masses, it's probably a moon of some kind and a larger planet. So when I've set these up in my notebook, I've used the same colors, and I actually think that I've got my um, video thing here, my document camera, to showing the correct colors. So yay for that technical help. Um, so we're going to substitute in. So we've got force of gravity equals our G, which is 6.673 times 10 to the negative 11th newtons times meters squared per kilogram squared, times our first mass, times our second mass, times our distance, and that distance is squared. So make sure that you remember that you square the entire distance, and that is the entire distance, including your units here, which is a meter. Okay? So the next thing that I'm going to do is, or the first thing I'm going to do is I'm going to multiply these two values together. That will give me 4.365 times 10 to the 36th kilograms squared. 4.5 times 9.7 will give you 43.65. Well, we're going to put this in scientific notation. So it would give you 43.65, and this was a question from class. That's why I'm going through it again. It would give you 43.65, and then for a scientific notation here, it would be 10 to the 10th times 10 to the 25th. You'll add those exponents, so you'd have 10 to the 35th. But in order to put it in scientific notation, you move that decimal place over here. So it's 4.365 instead of 43.65. And when you move that decimal place over here, that means that there's going to be one more zero or one more place. So you have 10 to the 36th. Okay? So we've also done the work down here at the bottom. We have squared this whole quantity. So 1 squared is just 1. 10 to the 10th squared is 10 to the 20th. A meter squared is a meter squared. Okay? And I've circled this in purple and the teal so that you can see that this value right here came from those two numbers. Now I'm going to move on down to the next number, and I'm just bringing all of this straight down. So we'll move on to the next number, and that is taking this number and dividing it by this number right here. So I've got 4.365 times 10 to the 16th. And so that would be dividing 4.365 by 1, same thing. 10 to the 36th divided by 10 to the 20th. That's going to be 36 minus 20, which is going to give us 16. Got kilograms squared on top, meters squared on the bottom. So we make sure that we carry those units through. Now, I'm going to multiply this constant that exists over here that we've just been writing over and over again times this value That is the combination of our two masses divided by our distance squared. And when I multiply this out, I get 2.913 times 10 to the negative sixth newtons times meter squared per kilogram squared times kilogram squared per meter squared. Well, that's super handy for us because if there's a meter squared on top and a meter squared on the bottom, we can cancel those out. There's a kilogram squared on top and a kilogram squared on the bottom, we can cancel those out. And we're left with a newton. And so what we look at for that answer, after we've simplified our units, is the force of gravity is equal to 2.913 times 10 to the negative sixth newtons. That's a pretty small force of gravity between them, but this is what our force of gravity is. What I've put down here at the bottom and what you can see in one of the screenshots that I uploaded is how I would put this in on a TI 30X calculator. So this is my calculator right here. And so I'm showing you the different screen or button inputs that I'm doing in order to do some of these calculations. So hopefully this will help. And if you want to look at it a little bit closer, there is a screenshot of this part. Okay. What I would like you to do now is to pause for just a moment, and I would like you to try the next value or the next problem. So this is, I just showed you how we got this one. What I would like you to do is take the notes that you just took from my explanation, and I would like you to work out the next problem with the 2 times 10 to the 10th. Pause right now, please, and do those calculations. Okay, now that you are back with me, I'm going to switch us over to my notebook again. And here are the calculations for the second distance. So the masses are the same, the distances are not the same. So I'm not writing all of my givens over again because I have them on the front page. You can write them over again. You don't absolutely have to. Because we're basically not changing anything except the distance. So I've got G times my first mass times my second mass. That number is going to be the same, divided by my distance, and that distance is squared. So I've got 2 times 10 to the 10th meters, and that whole quantity, that's my whole distance, is squared. So this time, instead of just bringing this number straight down, because a 1 squared is just a 1, now I've got a 2 squared. So a 2 squared is a 4. So now I have 4 times 10 to the 20th meters squared. When I do my math here, so taking this number and dividing it by this number, I get 1.091 times 10 to the 16th kilograms squared per meter squared. When I multiply G times this combined number here, I get 7.28 times 10 to the 5th newtons times meter squared per kilogram squared times kilogram squared per meter squared. That meter and that meter, that meter squared and that meter squared cancel. That kilogram squared and that kilogram squared also cancel. And so I'm left with a newton. So my force of gravity is 7.28 times 10 to the 5th newtons. If you don't have this done correctly, then go back through, look at what I did, and see if you can figure out what you did incorrectly. If you're having trouble punching the numbers into the calculator, then go back to the screenshot that I gave you of how to punch numbers in. Make sure that you're punching in that like this is a whole quantity. So 1.091 times 10 to the 16th, that's a whole quantity. You don't want to multiply these two together. It's not separate. This is a big, long number written in scientific notation so that it's easier to fool with. One thing that we talked about in class today is that I make sure that my TI is in, oops, I went to the wrong thing there. I make sure that my TI is in scientific notation or scientific mode, and I do that by pushing second and this DRG, and I want to go. I want the scientific here, and if it's not in that, I can just punch this side button over until the SCI right there is underlined, and then I push enter down there at the bottom. Okay. When you have finished with checking this answer here, making sure that you understand how I worked through that and understanding any mistakes that you might have made, go ahead and go back over here and try changing your distance again. So now we're going to have 4 times 10 to the 10th meters separating these two objects. And then the last one will be 6 times 10 to the 10th meters separating these two objects. I want you to work on those on your own, trying to figure them out um, so that you can, so that we can work with these numbers over the next couple of days. Please remember that we have a quiz over Kepler's first law and that you need to make sure that you get this homework done so that you can take your quiz on Thursday. We will not be able to use notes on the quiz. So your quiz won't be open notes. So you're going to need to make sure that you are ready to take that quiz. Okay, thanks so much. Hope you have a lovely evening. And it's 6:30 now. I'm going to go home. See you guys on Thursday.